A road may look simple on the surface, but its strength is built layer by layer beneath. Today, we will learn how roads are constructed under normal climatic conditions. Road construction in extreme climatic conditions is covered in separate videos on this channel. Please refer to our playlist for those videos. In this video, we will understand how proposed new roads are constructed, starting from subgrade, subbase, wet mix macadam, and asphalt work. We will also see the key role of surveyors at every stage, along with all technical details and execution procedures, explained step by step. In addition, we will learn how existing roads are modified and upgraded to match the proposed road standards. Now let us begin. Do you want to learn the real secrets of civil engineering, the kind of knowledge most experienced engineers never share? Welcome to Civil Guru Solutions. This channel is dedicated to revealing the hidden side of civil engineering and explaining it in a simple, practical, and easy-to-understand way for everyone. Here, you will explore every stage of the profession: design, quantity surveying, estimation, scheduling, execution, and quality control. To make learning accessible worldwide, our videos are available in multiple languages: English, Spanish, French, Portuguese, Arabic, Hindi, Tamil, and many other international and regional languages. You can choose your preferred audio language from the YouTube settings at the bottom of the screen. If you find our content helpful, please like, share, comment, and subscribe. Thank you for being a part of Civil Guru Solutions. Together, let's learn, build, and succeed. In this episode, we will discuss the project of widening an existing road from 2-lane to 4-lane. In this, we will see how the existing road is modified and how the proposed road is developed. Before going into detail, let us first look at the existing road and the natural ground surface. In general, the proposed road is taken as a priority for development because it can be started immediately without affecting the existing traffic. Also, this proposed road can be used as an alternative route while developing the existing road. So now we will see the development of the proposed road. Site preparation. First, before starting any work, the reduced levels of the natural ground surface shall be recorded. These levels help in calculating the quantity of excavation carried out during the cleaning process. Usually, the subgrade requires basic preparation to make it suitable for construction. This process is known as subgrade formation or reducing to level. It is a bad practice to construct pavement over surface vegetation or topsoil. As it contains organic material, this material will decompose over time, which can lead to the formation of voids in the layers above, resulting in settlement of the pavement. The simplest form of subgrade formation is side stripping. This process involves the removal of all surface vegetation, including the root zone and any topsoil. Most projects require some degree of excavation to reach the formation level. There are two common reasons for this: to achieve the required finish levels of the pavement, and to remove bad ground, soft spots, or other unsuitable material. After completion of site cleaning, the top surface of the cleaned ground shall be compacted lightly. Then, the reduced levels shall be recorded again before starting subgrade filling. This helps in calculating the quantity of embankment required. Please check. The different methods of calculating earthwork quantity are discussed in another video in this channel. The next item of work is subgrade. It is also known as embankment. Subgrade. For most construction works, the required pavement thickness is designed and known in advance. Once the finished road level is established, the thickness of the pavement layers is subtracted to determine the formation level. The formation level is the uppermost surface of the subgrade. The subgrade is the base of the road construction. It will be overlain by other pavement layers. If the ground is structurally weak, likely to be subjected to exceptional loads, or is significantly below the required formation level. Specified subgrades consist of layers of earth fill, obtained from selected borrow pits. The scope of work includes excavation, loading, transportation, laying, leveling, watering with potable water to achieve optimum moisture content, and thorough mixing before compaction. Compaction shall be carried out to achieve at least 95% of relative density. For highways, modified Proctor density is used to determine the relative density. The specifications to be followed are as follows. The selected soil shall have a minimum soil bearing capacity of 1 and above. The optimum moisture content shall generally be within 5 to 6%. The plasticity index of the soil shall be between 1 to 5%. If the plasticity index is between 0 to 1%, the soil is considered as sand, which may slide out of the embankment during the rainy season. If it is above 5%, the soil is considered as clay, which is also not suitable for road construction. The next item of work is subbase. Most pavements rely on proper support. Subbase. The subbase layer is the main load-bearing layer of a pavement. It is designed to spread the load of the pavement and any traffic acting on it evenly to the subgrade below. The interlocking between adjacent particles of the subbase material ensures the ground's ability to carry heavy loads. Generally, two types of specifications are followed for subbase construction. One is unbound granular subbase, and the other is cement-bound subbase. Cement-bound subbase is a cost-effective method to construct a heavy-duty and durable pavement within a shorter time. It offers an alternative to traditional flexible materials. The binder material can be rapid-setting, such as cement, or slow-setting materials like PFA and slag. However, unbound granular materials are most commonly used for road projects. These materials are generally available in riverbeds in many regions. In some areas, the natural ground itself contains blended subbase material. The material shall be spread in uniform layers, such that the compacted thickness does not exceed 200 to 250 millimeters, considering the loose thickness required for compaction. Each grada pass shall overlap 1/3 of the blade length. The moisture content shall be checked for optimum moisture content. If it is less than required, water shall be added by sprinkling. If it is more than required, the material shall be exposed to sunlight until it reaches optimum moisture content. Compaction shall be carried out mechanically using vibratory rollers of 80 to 100 kilonewtons static weight, covering the entire width of the pavement. Rolling shall commence from the lower edge and proceed towards the upper side with 1/3 overlap. Generally, 6 to 8 passes are required to achieve about 98% of laboratory density. Each layer shall be tested using the sand replacement method. The specifications to be followed for subbase are as follows. The selected blend shall be free from organic materials and shall have a minimum soil bearing capacity of 2 and above. Normally, good granular subbase materials have a bearing capacity greater than 3. The grading of material shall conform to the designated sieve analysis. The maximum size of granular material shall pass the 75 mm sieve, meaning that all particles used in subbase shall be less than 75 mm in size. Higher quality subgrade soil may be blended with granular aggregates to improve durability. Typically, a mixture ratio of 1:2 by volume is used, that is, 1 part granular aggregate and 2 parts good subgrade soil, thoroughly mixed to produce suitable subbase material. Now, we will see the role of surveyors. This type of survey work is repeated in every stage of execution to control the width and thickness of all pavement layers, such as wet mix and asphalt works. Before the commencement of any work, the toe line shall be established by fixing pegs to mark the limits of the granular subbase. The pavement width for the toe line shall be calculated based on drawings, considering the formation width, offsets, slopes of different layers, and the depth of the current layer from the formation road level. Control pegs shall be fixed at intervals of 10 meters on both sides of the bed, in such a way that they are not disturbed during grading. Pegs at 5-meter intervals are recommended in curved sections. The required level of the pavement top shall be marked on the pegs, with a suitable vertical offset. After rough initial spreading, a cotton or nylon string, known as line dory in Hindi, shall be stretched between the control pegs on both sides. The height of the string from the bed surface shall be measured at a fixed horizontal offset. Based on these measurements, the grader operator shall be instructed to carry out cutting and filling at each point. Now the next item of work is wet mix macadam. Wet mix macadam. Wet mix macadam is the next generation of water-bound macadam, and it is intended to be an alternative and more durable pavement for road and highway works. It is generally used as a base course. In flexible pavements, WMM provides uniform and strong support, with high resistance to deformation and distress. Wet mix macadam shall be prepared as per the approved proportion of aggregates in a pug mill plant with controlled addition of water. Water shall be maintained within limits, generally 1 to 2% above the optimum moisture content, to compensate for evaporation losses depending on the lead distance and seasonal conditions. The mix shall be transported from the plant to the laying site. If the existing subbase surface is found to be dry, water shall be sprinkled before laying the wet mix. Considering compaction, the loose laying thickness shall be kept 15 to 17% higher to achieve the required compacted thickness. A test trial shall be conducted to determine the number of passes required to achieve 98% of relative density. The rolling sequence shall typically consist of one initial plain pass, followed by 2 to 3 low vibration passes, and finally one plain pass at the end of compaction. The speed of the roller during compaction shall not exceed 5 km per hour. Generally, high vibration passes are avoided in wet mix, as they may crush the aggregates, which can reduce the durability of the pavement. Similar to subbase, surveyors shall fix control pegs at intervals of 10 meters on both sides of the bed, and the same procedure shall be repeated to control the width and thickness of the pavement. The level of the finished layer shall not vary from the project design level for that particular layer. The tolerance for surface levels of wet mix shall be within plus or minus 10 millimeters. To check compliance with this requirement, measurements of surface levels shall be taken on a grid of 10 meters longitudinally and 3.5 meters transversely along the pavement. The average of 10 measurements shall not exceed 3 millimeters above the permitted limit. The specification of materials for wet mix macadam shall include gravel of 0 to 6 millimeters crushed aggregates and stone aggregates of 6 to 50 millimeters. The proportion of this blended material shall conform to the grading requirements as per the relevant specifications. In India, Morth Section 400, Table 13 is followed. The next item of work is Kerb stone. Kerb stone. The Kerb stone provides clear physical and visual marking and delineation. It makes drivers aware of the pavement and greenery areas, helping in the proper demarcation of roads, streets, and car parks. It provides a clear view of the carriageway and helps in preventing any kind of lateral spreading from the carriageway. There are many types of curbs available. The types are mainly based on the purpose of use and the type of materials used for manufacturing. They are also available in different textures, colors, and standards. Where the central medians are very narrow, high-raised concrete dividers are used to separate the carriageway. The specifications to be followed are as follows. High-strength concrete shall be used for curbstones to withstand vehicle loads and traffic pressure. Expansion joints shall be provided at intervals of 10 meters. Haunching shall be provided to support the curbstone. Now we are going to see the asphalt work. Asphalt work. Asphalt work is the most expensive and important activity in a road project. It involves the following items of work. First, the prime coat and tack coat. Second, bituminous macadam. Third, dense bituminous macadam, also known as DBM. And fourth, the wearing course or asphalt concrete. The prime coat. The prime coat is the binding layer between bituminous and non-bituminous surfaces, such as wet mix macadam. Cutback bitumen grade 70 is used as a prime coat. The material shall be heated to a temperature of around 150 to 160 degrees Celsius properly blended for 2 to 3 hours, and uniformly sprayed at approximately 1 kilogram per square meter over a dry and clean wet mix surface using a mechanical sprayer. Normally, it shall be allowed not less than 24 hours to penetrate into the wet mix before laying asphalt. The tack coat. The tack coat is the binding layer between two bituminous surfaces. Bitumen of grade 80 to 100 is used for the tack coat. It shall be heated to around 150 to 160 degrees Celsius and uniformly sprayed at about 0.5 kilograms per square meter using a mechanical sprayer. It is generally applied just before laying the next layer. The next item of work is dense bituminous macadam, also known as DBM. Dense bituminous macadam. DBM consists of laying 1 or 2 layers over a previously primed and approved wet mix macadam in accordance with project specifications. Each layer shall not exceed 100 millimeters in thickness. The materials used include coarse aggregates, fine aggregates, and binder content. The coarse aggregates shall be a blend of crushed aggregates ranging from 6 millimeters to 25 millimeters, and they shall be cubical or angular in shape and satisfy all required specifications. Fine aggregates shall pass the 2.36 millimeter sieve and be retained on the 75 micron sieve, consisting of crusher run screenings. An important information is that the natural sand is not allowed as fine aggregate in any asphalt work. Generally, bitumen of grade 80 to 100 is used as the binder in highways. The percentage of binder content shall be determined based on the requirements specified in the contract and the traffic volume. The Marshall test method shall be adopted to determine the optimum binder content. Normally, the percentage of bitumen used for DBM is between 4.0 to 4.5%, in addition to meeting grading and quality requirements of individual ingredients. The mix shall satisfy all project specifications. The job mix formula shall be prepared and approved by the client before starting asphalt work. The formula shall be within specified limits and meet all quality control criteria. After approval, plant trials shall be conducted to confirm the bituminous mix design. Construction procedures to be followed include weather conditions. Laying work shall not be carried out during rainy or foggy weather, when the base surface is damp or wet, during dust storms, or when the atmospheric temperature in shade is less than 10 degrees Celsius. Preparation of the base is essential. The surface shall be free from dust and foreign matter. It shall be cleaned using a mechanical broom or compressed air. Transverse joints shall be cut vertically using an asphalt cutter, and a coat of hot bitumen shall be applied before placing the new material. Prime coat or tack coat shall be applied as per specifications. The DBM mix shall be produced in a hot mix plant on a batch basis by weight. Mixing shall be carried out in a twin-shaft pug mill to produce a homogeneous mix. The mixture shall be transported from the batching plant by tippers, and if required, shall be covered with tarpaulin to maintain temperature and prevent dust spread during transport and laying. The mix shall be discharged slowly into the paver hopper while both the tipper and paver move forward steadily, wherever possible. Paving shall be carried out in a single pass for the full width of the road to avoid joints. The temperature of the mix at the time of laying shall be between 140 to 160 degrees Celsius and shall not be less than 120 degrees Celsius. Automatic sensors on the paver shall ensure proper line, grade, and level. These sensors are guided by string lines fixed by surveyors using stakes and arms on both sides, typically at 0.5 meters from the edge. Compaction shall begin immediately after laying the mix. Rolling shall be carried out using a set of rollers, moving at a speed not exceeding 5 kilometers per hour. The rolling sequence shall be as established during the trial stretch. Compaction shall be completed before the temperature falls below 90 to 100 degrees Celsius. Joints shall be rolled immediately after paving. Rolling shall commence longitudinally from the lower edge towards the upper edge, parallel to the center line of the pavement. Rolling shall continue until all roller marks are eliminated from the bituminous surface. During rolling, the wheels of rollers shall be kept moist by sprinkling water from the roller's water storage system to prevent the mix from sticking to the wheels. The tolerance for surface level shall be within plus or minus 6 millimeters. The specifications for aggregates are as follows. Water absorption shall not exceed 2%. Impact value shall not exceed 27%. Flakiness and elongation index shall not exceed 35%. Los Angeles abrasion value shall not exceed 35%. The stripping value shall be a minimum of 95% retained. The next item of work is the wearing course, also known as asphalt concrete. Asphalt concrete or wearing course. The wearing course is the final and finishing layer of asphalt work. The material selection and construction procedure are similar to dense bituminous macadam. However, the difference between DBM and the wearing course is the grading of the mixed aggregates. The maximum size of aggregates used in the wearing course is less than 20 millimeters. Approximately 4 to 5% of filler materials are used to obtain a smooth finished surface. In projects such as airport runways, lime powder or cement is used as filler material to ensure a fully smooth top surface. The percentage of binder material, that is bituminous content, in the wearing course is slightly higher than in DBM. This layer is generally laid as a single course with a maximum thickness of 100 millimeters. Now we will see how the existing roads are modified. Existing road. Normally, the existing road has camber and slope on both sides. When the existing road is developed into 4-laning, the slope on both sides is not required and it is corrected to a single side slope using camber correction layers. Bituminous macadam. Bituminous macadam is used for camber correction layer and it is generally laid in 2 layers. The specifications and method of construction for bituminous macadam are similar to DBM and wearing course. However, the gradation of aggregates for bituminous macadam varies from other asphalt mixes. In this mix, 25 mm aggregates are used as the maximum size, and the percentage of binder material, that is bituminous content, is slightly lower than DBM. Once the camber correction is completed, similar to the proposed road, curb stones shall be fixed at the edge of the existing road. Then DBM and wearing course shall be laid, similar to the proposed new road specifications. The next item of work is shoulders. Shoulders. The shoulder is a necessary part of highways and it serves several functions. It provides lateral support to the highway pavement. It helps protect the highway surface from the intrusion of water, which is one of the major causes of pavement damage. A wide shoulder also provides a temporary parking area for vehicles, allowing people to stop when required. Typically, a single layer of road base of about 10 centimeters thickness, along with a thin layer of asphaltic screed, is used as the topping for shoulders to seal the road base. Finally, miscellaneous works shall be completed. If this episode changed how you see highways, you are already thinking like a highway engineer. This is the common procedure used in road construction projects. However, materials and construction procedures can vary, especially in extreme climatic conditions. To learn more about those construction methods, please refer to the related videos. The links are provided in the description for your convenience. Subscribe to Civil Guru Solutions. Here, we do not just explain how roads are built, we explain why they survive or why they fail.